In this video, I want to talk about how we might be able to reason through to solve division problems without using a longhand division procedure. Let's suppose we have the problem that we want to put 110 candies into packages of 8 candies each. How many packages can we make and how many candies are left over? Well, we want to try to reason through this, and one of the ways we can do this, 10 packages would give us 10 times 8, a total of 80 candies. So now we've accounted for 80 of our candies. 3 packages would give us 3 times 8, or a total of 24 candies. So far we've dealt with 80 plus 24, or 104 candies. And we have 10 plus 3, or 13 packages. We then have that 6 more candies would get us to the full 110 that we have. That's not enough for one package, so it would tell us how much is left over. So total what we did was 10 times 8 plus 3 times 8 plus the extra 6, so the 10 times 8 from the 10 packages, 3 times 8 from the 3 extra, 6 left over is equal to 110. I can use the distributive property here to write this as 10 plus 3 in parentheses times 8 plus 6 is equal to 110. Or 13 times 8 plus 6 is 110. And this also helps us see what's happening. 13 packages of 8 candies each with 6 left over. So in order to solve this problem, we repeatedly added multiples of 8 until we got as close as possible to 110 without going over. Let's look at another way we could have done this. We could say that 10 packages gives us 10 times 8, or 80 candies. 110 minus 80 tells me that I have 30 candies left over that I've not accounted for. 3 packages would give us 3 times 8, or 24 candies. 30 minus 24 would give me 6 candies left. So we have a total of 10 plus 3, or 13 packages, with 6 left over. We can write the equations to explain how we did our reasoning. This time we did 110 minus 10 times 8 to get 30. 30 minus 3 times 8 to get 6. And we could combine these into a single equation. 110 minus 10 times 8 minus 3 times 8 is equal to 6. Using our distributive property, I can write this as negative 10 plus 3 times 8, or 110 minus 13 times 8 is equal to 6. So while the first method looked at repeatedly adding multiples of 8, this approach starts at 110 and repeatedly subtracts multiples of 8. So this shows us that in order to divide, we can repeatedly subtract multiples of the divisor, or we can repeatedly add multiples of the divisor. So this is how we might be able to work through a division problem without knowing one of our algorithms.